Hello and welcome. Today we're going to talk about the difference between a statistic and a parameter. So we have this example here. It says researchers collected data on bored high school students. When taking a sample of 9,001 students, they found that on average, a student in high school will spend 3.2 minutes sleeping in a given class. Now, when we analyze this, there's a few numbers that pop out. There's this 9,001 and there's this 3.2. The 9,001 is going to be the sample size. This number, 3.2, summarizes the data we have about these students. It tells us about how many minutes we can expect a single student in a single class to spend sleeping based on this sample. Now the question is this a statistic or a parameter? Well, this is actually a statistic. This 3.2 is a statistic. I'll say X bar for my mean, my statistic mean, and I'm going to set that equal to 3.2. But why is this not a parameter? What's the difference? Well, the difference is that this 3.2 does not refer to the actual value for all of the students in the planet or a certain country or whatever your population is. This is a sample value. This is a value summarizing your sample. This 3.2 tells us about the 9,001 students that we tested. As a number which summarizes information about a sample value, we call it a statistic. A parameter is a summary value which refers to the actual value for all of the students or all of your population. So if I went to my entire population of high school students in whatever area I care about, the entire population, and I found that on average they spend 3.5 minutes sleeping, that would be my parameter. I'm going to use the symbol mu for that. So a statistic is a summary value that refers to a sample. A parameter is a summary value that refers to the entirety of the population. Often, you have no idea what this is. Usually, you can't figure this out. Populations are often too large, too cumbersome, and too expensive to calculate information about. And so you take samples and try and estimate the parameter. Statistics are values that are used to estimate parameters. They're used as stand-ins when you don't have the ability to find the actual parameter. And that's okay. Often they're pretty close to the mark. Let's check out another example and we can get a better idea of what the difference between a statistic and a parameter is. Let's check out this example. So here we have a group of students decided to test what percentage of short form videos contain an AI voiceover. They tested 1,337 videos and found that 1,146 contained an AI voiceover. So what important information are we given here? Well, we can see that they tested 1,337 videos, and from that testing, they found this many contained an AI voiceover. How would I label these? Well, if this is the number they tested, I would call that the sample size. I would say the sample size n is equal to 1,337. This 1,146 is not actually a summary value because it is not standardized for the size of the sample. If the sample was a billion, this number would have a very different meaning. And if the sample was exactly 1,146, it would also have a different meaning. So what I'm going to do to calculate a summary value is take this 1,146 and divide it by my sample size. So I get 1,146 divided by 1,337. And that equals 6 over 7, which is about equal to 0.86. So this is going to be a proportion. This is the percentage of videos that we found to have an AI voiceover. The question is this percentage here a statistic or is it a parameter? The answer is that this is a statistic. Why is it a statistic? Because this number only refers to the percentage found in this sample. This is not the true value for all the videos ever made, all of the short form videos, or any other category, any other actual population. So because this refers to a sample, this is a statistic. And how we write a statistic for a proportion is we use p hat. So I would say that p hat is equal to 0.86. Now, what would the parameter be in this situation? In this situation, a parameter would be the proportion of all videos in the entire world or whatever category you care about actually contain an AI voiceover. So if, for example, we found that via extensive testing of every video ever made in the world, that the actual percentage of AI voiceovers is something like 0.7, especially because this could include videos from far into the past, I would say that P is equal to 0.7. This is how you write the parameter for a proportion. This is a parameter. So as an overview, you know it's a statistic if it refers to a sample. A statistic is a summary value referring to a sample. You know it as a parameter if it refers to a population. A parameter is a summary value that refers to the actual population. A statistic is most commonly what you will see because it is very hard to get information of a whole population. I don't want to go through billions and billions of videos to find out what percentage have an AI voiceover. So I take a limited sample, I get a statistic from that tells me it's about 0.86 or 86%. And then that can let me infer things about the population. I can guess that the proportion of AI voiceover videos in the actual population, also known as the parameter, is about 0.86. In this case, in this made-up example, I'd be wrong, but that's okay. That's how statistics work. I cannot know everything. I can only do my best to guess a close estimate and work with what I've got.